Welcome back to Engineering Mathematics KS 303. Today we will study pigeonhole principle. This is a very important topic in the counting mathematics and it's related to permutation and combination little bit. So it's a very practical principle and used in many real life problems. So let's start with pigeonhole principle. Pigeonhole principle. Let's see the statement of this principle. So if n pigeonholes are occupied by n plus 1 or more pigeons, then at least one pigeonhole is occupied by more than one pigeon. Suppose you have some pigeonholes. Hole 1, pigeonhole 2, pigeonhole 3. And if you have 4 pigeons, P1, P2, P3, P4, then if this number is more than P4 or more than n plus 1 or more than n plus 1. So more than 3 means 4 or 5 you can take. So if you keep one here, one here, one here, then P4 and P5 will be also kept in S3 or H5. Means at least one pigeonhole is occupied by more than one pigeon. So it's a real problem. Like we have 13 professors in my department, and if we want to know the birthday month, for example, if there are 13 professors in a department, then two professors were born in the same month. So month is actually pigeonhole and professors are pigeon. So we want to accumulate 13 professors in 12 months. So there will be at least two professors which have birthday in same month. Or all 13 can have birthday in same month. But my target is at least 1 month has birthday of 2 or more than 2 professors. So this is a practical problem based on pigeonhole. Let's see the next example. Suppose you have a bag. In the bag, some red socks, some blue socks, and black socks. And many numbers are many. We don't know the exact number. Many red, many blue, and many black socks are there. And we want to pick 4 socks. So if you see carefully, 4 socks is your pigeons. And these 3 colors are pigeonholes. Then you will see that there will be two, there will be a two or a pair. There will be a pair means two of socks of same color, of same color. Because you want to take four, so suppose you take one red, one blue, and one black, then fourth you have to pick out of three colors only. So if you take red, then red socks will be two. So this is again a pigeonhole principle concept. Now, generalized pigeonhole principle. If this is important, if n pigeonholes are occupied by kn plus 1 or more pigeons, where k is positive integer, k is positive integer, then at least one pigeonhole is occupied by k plus 1 or more pigeons. So same number will come here. This is generalized. If you put k equal to 1, then you will get previous result. If you put k equal to 1. For example, find the minimum number of students. Find the minimum number of students in a class to be sure that three of them were born in same month. Let's see the solution. You want the minimum number of students in a class to be sure that three of them were born in the same month. So you can feel this question actually. Suppose there are how many months? There are 12 months. So this is your pigeonholes. Because birthday should be false in 12 months only. Now, if you take 24 students, for example, then in every month you kept two birthday, then there 24 student can have two birthday in January, two birthday in February, and so on, two birthday in December. Then 24 students are accommodated in 12 months, but you want three. So after 24, if you have 25 students, then 25th student must have birthday out of 12. So 25 students are needed. This is little thinking because the problem is simple and you can think over it. But by the pigeonhole principle, you can solve more rigorous and difficult problem using that same technique. How? You want k plus 1 pigeons. You want how many birthday actually? You want 3 birthday. You want k plus 1, 3 students birthday. So the k will be 2. Now you put k equal to 2, you will get number of pigeons or number of students. Here, number of students or pigeons or number of pigeons will be kn plus 1, or you can say 2 into 12 plus 125. So if you have 25 students, then you will be sure that surety is important here, because in the 24 you are not providing surety, because two students can have birthday in every month, but 25 student is giving surety that three students have birthday in same month. Let's see the next example. Same socks example I am going to take here. I've discussed it previously. A bag contains many red, comma, white and blue socks. Find the minimum number of socks that one needs to choose in order to get two pairs or four socks of the same color. You want two pairs or four socks, because don't see problem. This is meaningless. Four socks is important. So you want how many minimum number of socks in the bag. This is your suppose bag, and there are bag uh, red socks, white socks, and blue socks, and you want same same color four socks. So you can think over. I can kept three red, three white, and three blue. But you want four of same color, so you have to give plus one also of any color. It can be white, it can be blue, it can be red. So ultimately, you can get four socks of same color. Same color. It can be of red color, it can be of white color, or it can be of blue color. So answer is 10, because the problem is simple here. But by pigeonhole, you can also solve this. Let's see the solution. Number of pigeons are 3. Colors are pigeonholes, because you want the socks of the color 3 colors, and you want 4 socks of same color. So k plus 1 is 4 here. So k will be the 3. So number of minimum, this will give you at least or minimum socks, or number of minimum pigeons. Here socks will be play as a role of socks will be kn plus 1. So 3 into 3 plus 1, you can see that 10. 10. Similar example I am giving you as a homework. Find the minimum number of students needed to guarantee or surety, you can say, that one of them belong, needed to guarantee that five of them belong to the same class. Class, can you see first year, second year, third year, fourth year? So this is a example. I'm giving the answer. Answer is 17. You can solve it. Two question I'm giving you as an assignment, and you all submit this assignment up to Friday. Up to Friday. Submit this assignment up to Friday. Two questions are. First question is, let capital L be a list, not necessarily in alphabetical order of the 26 letters in the English alphabet, which consists A, E, I, O, U as vowels and 21 consonants. So that first problem, so that L has a sublist consisting of consisting of four or more consecutive consonants. Sonants. Second problem, assuming L begins with vowel say A, so that L has a sublist consisting of five or more consecutive consecutive consonants. So this is the first problem of assignment. Second problem of assignment is like this. Find the minimum number n of integers to be selected from set 1 to 9, so that first is the sum of two of the integers of the sum of two of the n integer, the sum of two of the n integers is even. Second is the difference of two of the n integers is 5. So these are two problems based on generalized pigeonhole principle, and you all have to submit this up to Friday. Now the another form of generalized pigeonhole principle, if we find the value of k in the form of greatest integer function. So this is the most important form. If m pigeons occupy n pigeonholes, m greater than n, then at least one pigeon hole has more than greatest integer m minus 1 over n plus 1 pigeons. This symbol is representing here greatest integer. For the definition of greatest integer, you can see my lecture 14 in the gate series. Let's see some example related to generalized form. First example is, always remember pigeons are greater than pigeonholes. So sometimes you can be confused selection of pigeons and pigeonholes. So remember that pigeonholes will be less than pigeons in my 99.99 problems. So that the among 100 pupil, at least 9 of them were born in the same month. Month is not mentioned here. That can be January, February, any month. So let's see the solution. We have to prove 9 months. So there are m is a number of pigeons. It is 100. N is a number of pigeonholes. We want to accumulate the birthday in 12 months. So the formula for how many pigeons can be kept in a one pigeonhole is equal to greatest integer m minus 1 plus minus 1 upon n plus 1 is equal to 100 minus 1 by 12 plus 1. So it is 99 by 12 plus 1. If you divide this 12, it's 96.25 nearly plus 1, I think. So the greatest integer of 8.25 is 1. So 8.25 greatest integer will be 8 plus 1. So 9 people are born in a same month. In a same month. Let's see the next example. So that I'm giving you this as a homework. These are similar problems. If 25 dictionaries in a library contain a total of 40,235 pages, then one of the dictionary means one of the pigeonhole must have at least 1,641 pages. Is the next example as a homework. So that if 7 colors are used to paint 50 bicycles, at least 8 bicycles will be the same color. Next, I am giving you, if we select any group of 1,000 students on REC Kannauj, in REC Kannauj, so that at least 3 of them must have the same birth day. Here I am asking day, not month. Important point is day. Example. Next example for practice is, so that if any 11 numbers from 1 to 20 are chosen, then 2 of them will add up to 21. You have to select like 1 comma 20, 2 comma 19, like this. Some must be 21. Next example 5. Find the minimum number of students needed to guarantee that 5 of them belong to the same subject having majors as English, maths, physics, and chemistry. So these are the practice problems, and you can try these problems. If any doubt, you can ask. Okay, thank you.